What's up, guys? Welcome back to another episode of the Unreal Hour. Whether this is your first episode or your 100th episode, which is impossible, by the way, since this is the second episode, regardless, I appreciate you joining me. My name is Aaron. I am the owner and development lead at Blind Eye Studios. And if this is your first time, what the Unreal Hour is, what you're about to get yourself into is not necessarily a tutorial series. You certainly can learn some tips and tricks from it, but it's not a tutorial series. It's more of a devlog where you guys get to sit in and see some of my development process as I work on today work on a new game for the second episode. And if you missed episode 1, you definitely should go check it out. We started a brand new project, brand new game called What Ravens Like. And in that episode, we set up essentially our player character, a young boy. We got some movement going on with some custom camera behavior, which is pretty nice. Oh, got some screen flicker going on. That's fun. And so tonight, we will be diving into creating his companion. And by the title of the game, you may have guessed that will be a raven. So let's jump right in. We'll show you what I'm working with. We've got this asset of a raven, pretty cute little low poly guy, and so we are going to be getting this raven moving and namely following the boy. So last episode we added an anchor component, if you will, to the boy's mesh, and that anchor is right here. And so that is our goal, is to have the raven follow the boy around at that anchor point. So let's get right into it. So I contemplated having the raven be part of this blueprint, and almost immediately that felt wrong. The raven needs to be its own entity, its own character or pawn, if you will. And so that's actually exactly what we're gonna do. So blueprints, characters, we've got the player. Probably should rename this to boy because I'm thinking, I'm still playing with this idea, but I'm thinking that at some points in the game, to solve certain scenarios, you may actually switch to controlling the raven. So then the folder name player doesn't necessarily make sense. But anyway, for now, we will have a raven. And so we are going to, I'm going to make him a pawn. So we'll have, I don't want to name a pawn, BP raven. All right, so we will open raven up, dock him here in the browser. Okay, now let's see. How do I want to do this? We're going to... Alright, so we've got a default scene root. Cool, that's fine. I'm going to add one more component here. I don't know that I'll need it at this point, but just in case, I'm going to call this the mesh anchor. And then on the mesh anchor, we will attach a skeletal mesh. And then we'll go over here to the details. And in the skeletal mesh, search for Raven. And there he is. Cool. So we've got our Raven. I don't need to relocate him, but what I do need to do is rotate him because he does need to be facing forward. So we'll move him, or rotate him 90 degrees. And then, what do I want to do? Okay. So, this Raven is definitely initially going to be controlled by AI. So, we're going to get blueprint is going to be, oh wait, I want all classes. And then I just want to search for AI controller. We'll choose this one. We'll name it AI controller for the Raven. Now we'll open this guy up. And so, I find so basically the first thing I want to do is I want to get a reference to our Raven for the controller. And so to do that, there is an event called onPossess, which very conveniently gives us a reference to the possessed pawn. Now, we know that we're using this AI controller for this Raven. So I'm going to go ahead and cast it to the BP Raven. We're only doing it once, so no worries about casting performance issues. I know a lot of people like to get up in arms about casting. You should never cast. It's okay. Calm down. We'll just call it Raven. Cool. And then what do we need? I think that might be all we need for the moment. Yeah. Looking at some notes here. Okay. Yeah. So, one thing that we're going to need to do, we need to do this carefully. So our Raven initially, right? So the Raven's default behavior is going to be just to follow the boy. Wherever the boy goes, the Raven will follow. So what that means is that we need a reference in the Raven class to the boy. So, how do we want to do that? There's a couple options. We could, in the Raven class, we could look for the boy blueprint. I'm sorry, not the blueprint. We could look for the boy object. On event begin play. But okay. Let's do this. Let's create a function. We're gonna call it try get boy reference. And there's only ever going to be one boy in our scene. So we can do get actor of class. We'll call it boy. BP boy. And then we'll take that value. We'll promote it to a variable. And we'll call it boy. And so that is all we will do. Now, so in the event graph, on event begin play, we're going to call that. We're going to call try get boy reference. So then in the AI controller, on event possess from the Raven, we'll do this. We'll do get boy, and we're gonna turn this into a validated get. And if the boy is valid, then we're going to promote him to a variable as well. So we'll set the boy there. So when this AI controller possesses or takes control of the Raven, we're setting a reference to it. We know that one will be fine. Then we're going to try to get the boy from the Raven as well. Honestly, though, really, I don't. Okay, we're gonna change this up a little bit. Can I just copy this whole? Yep, sweet. We're gonna put this paste function try get boy reference. Yeah, we're gonna put that there. And then that way we're not relying on the Raven for anything. We'll just do this try get boy reference, and then this tries to get the reference. Cool. Try get boy reference. Sweet. Oops, what's wrong with this? Oh, no. Try get boy reference. There we go. Okay, for some reason it was still trying to target the Raven for that. Sweet. Okay, now the Raven, we can get rid of this. We can get rid of this. Yeah, that was like super unnecessary. Okay. So we're trying to get the boy reference. Sweet. And so at that point, here's where we get to do some fun things, like get into some AI behavior. So what we are going to do is we're going to go into our content drawer. We're already inside the Raven folder. So we're going to create a Blackboard. All right, so we'll go there. We'll name it Blackboard _ Raven. And so what a Blackboard is it's really just a list of variables, more or less, that your behavior tree will end up using, right? So we've already got a reference to self actor here. That's fine. If I click on it, you can see it's just a type object. Cool, whatever. Let's make a new key of type object, and we're gonna name it target actor to follow. Because the reason I say target actor to follow and not just boy is because there's a possibility that at some point, I may not want him to follow the boy. I may want him to follow a different actor. So this is just a better way to keep things generic and not tie yourself to just the boy following the boy. And then, like, you end up needing 1,000 different keys for everything that the Raven could possibly follow. This just takes care of it all in one nice, clean setup. Now, another thing that we're gonna need is an enumeration or an enum, which is essentially, let's just call it E underscore Raven state. Sorry, I interrupted my own train of thought. An enum or an enumeration is basically just a list of values, and you're saying, like, okay, for example, what we're doing right now, right? The Raven state. The Raven will have a finite set of states, and so this enumerator or enumeration, whatever you want to call it, essentially lists out those potential states. It doesn't have to be states, though. It could be colors. You can have an enum called color, and it could have a list of all the red, blue, all that fun stuff. All right, so the Raven state. So for right now, we'll just call it following. We'll just call it following. Following. That'll work. So we've got the enum. And the reason that I made that is because I want another key, and it's going to be type enum, and this is just going to be called Raven state. And we're going to make sure that we choose the correct enum. It's going to be of type E Raven state. I think for now, that's all we need in our Blackboard. Those are all the keys that we're going to use. Yeah. Sorry, I'm thinking ahead, and it's causing me to blue screen for a second. Okay, let's go here. Artificial intelligence, behavior tree. So let's call this BT for behavior tree. Raven. We'll save that. 1 second. Let me reference my notes real quick. Because I had some thoughts on how, oh gosh, I gotta stop hitting this mic. How to handle this. Yeah, that's how we're gonna, okay. Yeah. All right, so let's open up our behavior tree. First thing we want to do, okay, cool, it's already set. Our Blackboard asset, we're using the Blackboard Raven. And so the first thing we have is the root. And so a quick primer, I guess, on behavior trees is the way that they work is that an execution will drop down from root, and then based on different conditions that you set up, different behaviors will activate and trigger. So the first thing that we're gonna do is we need a selector, and basically what this selector is going to do is you can have multiple branches going off of them, and each so for example, if I just throw a sequence down here, right, so we're saying, like, okay, these are coming off of here, a sequence of actions is going to take place, or tasks, Unreal calls them. what I can do is I can add a decorator, and where is it? Oh, that's right. It's just called Blackboard. So if we click on that, it's a Blackboard-based condition, and essentially, we want to check Raven state is equal to following. So this selector, from left to right, it'll check each condition, and once it finds a condition that's true, it will then execute everything under it in this sequence. So what we need to do now, I'm gonna create a folder inside here real quick, and it's gonna be called no, let's just call it tasks. So in here now I can create a new task. It's going to go inside task. And so this is of type behavior tree task. We're going to call it follow. Yeah. Yeah, boy. It's funny because we made a boy, right? Anyway. Okay, so in a task, you want to kick things off with an event called I'm completely blanking on this. Maybe if I spelled event right. It's like receive receive execute AI. Okay, so basically when this task fires, you're gonna get a reference to the controller that is running the task and a pawn that controller is attached to, which makes it very convenient and excellent to use interfaces in this case. So we're going under blueprint interface. So BPI standing for blueprint interface. I guess we can just call it Raven for now. So what an interface does is it basically forms a contract with I always feel dumb saying this because I'm like, yeah, I'm literally just quoting the textbooks on this stuff. But it creates a contract between itself and the actor that implements it, and it says, hey, in my interface, I have certain functions, and you, as the implementer of me, agrees to write your own implementation of those functions. So, basically, this interface is saying, I'm going to have a function called follow actor, right? And let's change that to follow target actor, just for clarity. So we'll compile that, and then if we go back to our Raven, and in class settings, we can implement an interface here. We're going to implement BPI Raven. Now, if you notice, this little interfaces tab popped up over here. If we open that up, we now have an interface called follow target actor. If we right click on that, we can call implement. And so then we get a nice event for us to use called follow target actor. Now, why is this important? Because behavior trees could potentially execute this task many times over and over and over and over repeatedly, very quickly. What I said earlier, about casting. Without interfaces, we would have to take this pawn and we would have to cast it to a raven to gain access to a function called follow target actor. However, with the follow target actor interface, what that allows us to do is we can just take the pawn. Wait. I messed up just a little bit. I did not mean to give the Raven class the interface. I meant to give it to the controller. Because it's the controller that I want executing these tasks. So we'll add, there we go. Boom, boom, same thing. Implement event. Dope. Okay. So now back to the task. We take the controller and we can just simply type follow target actor. And you see it's basically sending a message via the interface. Now the reason that it's a message is that if this controller is indeed implementing the interface Raven, which I should probably change that to Raven controller. Anyway, whatever. I'll do it in a second. If this controller is indeed implementing this interface, then it will call the function in this guy. However, if it does not implement the interface, nothing happens. No harm, no foul. So we have follow target actor. So basically, let's do a little test real quick. We're just gonna print a string that says I'm an interface event. Woohoo! All right, I'm an interface event. Real quick, let's do, because I forgot to actually, we haven't actually attached the behavior tree here. So let's do this real quick. Let's add the Raven state here. Raven state. Cool. We'll compile. The default state is following. Awesome. Now on possess, after we try to get the boy reference, we will let's add one more variable. This one's going to be called target follow actor. This one is just going to be of type actor. Then once we try to get the boy reference, we're going to set the target follow actor to the boy. Because remember, like I said, the first time the Raven pops up, his follow target is going to be boy. Then we're going to run behavior tree. We're going to run the behavior tree for the Raven. Then get, what is it? Get AI Blackboard? Get Blackboard. So we're getting the Blackboard, and then we can set value as enum. So this is where we're passing values, kind of setting our initial values for the Blackboard. So we're gonna make a literal name, and the first thing that we're doing is the enum, which was called Raven state. And then we're just going to pass it to, ooh, get out of there. Just going to pass it there. And then there's one more that we want to do for now. We're going to do the same thing. I'm going to do this real quick because we're going to keep needing the blackboard. So we're going to promote that to a variable. We're just going to call it blackboard. Oop, didn't like that. Raven blackboard. There we go. So boom. Now we can use that. Oh, break link to set values. Cool. All right, so we're doing that. Then we can use the Raven blackboard again to set value as actor. Oh, as apologies, as object. And what did I name that? Target actor to follow. All right, literal target actor to follow. And we're going to make that okay, so just for consistency, we're gonna pass it our variable target actor to follow. Sweet. All right, so we've got values. We're telling our behavior tree to run. We're setting initial values in the blackboard, or the blackboard. So then we have the behavior tree, and I think I can just call the task here follow BT task follow. That's our task, right? Yeah. Or if I just take that, stick it on that guy, and get rid of that. Yeah. Because it's not really a sequence, it's just a singular task. And so, all right, so yep, it's gonna keep doing that. And oh yeah, that's right. We need to tell it end dear Lord, what is the name of that event? It's like an ending event. Finish execute. There we go. And we'll just mark it as a success. Because of the wonderful things he does. Basically because there's really no way to fail this simple task, so we mark it as a success. Okay. Boom. Target follow actor. Follow target actor. Right. Then we have this event. Have I implemented this yet? Yes. Focus. There we go. Okay. So if we go back, okay, that's right. We need to make sure that the Raven is actually using our AI. We want to use the AI controller for the Raven. So if I take the Raven and we stick him, let's stick him right here. What are those funky wing things? Did you guys see that? That was weird. Okay, anyway. And if I hit play, woo, we're getting called a lot. which is, you know, what I said would happen, right? This selector goes through and and actually this is pretty neat. If I pull this to the side and hit play, you can actually see the executions happening. It's just going berserk. Seizure warning. It's a little late, but sorry. Okay, so we got that. Sweet. So now, how do we actually follow the boy, right? So let's do that. Let's. Where? Oh, it's right here. So one thing that and this is just, you don't have to do this. But I try to, and honestly, I'll probably move all of this stuff out as well into a function. One thing I like to do is to keep the event graph itself pretty clean. So if a function doesn't, or not clean, all of your code should be clean. Clear is what I meant to say. So if a function doesn't specifically need anything to do with time, I'll typically just move it to a function. And so like this one, for example, event follow target actor, I'll make a function called do follow target actor, right? And then from the event graph from here, I'll just call do follow target actor. Cool. So we're keeping our event graph very clear of clutter, delegating everything to a function where we can. Now, so what we need to do, oh wait, real quick, this will be fun. Just so our Raven isn't this static thing, right? Let's make him move a little bit. So we'll just pick an asset. Is that, no, wait, there's one where he's not gliding. He's not walking. He's not jumping. Where is that? I know I saw it earlier. Call death air. Oh no. Our Raven will not be dying. I promise that. Fly right. Fly stand? What is it? There we go. That's what I was looking for. Okay. So our little buddy's gonna be moving around, flapping his wings a little bit now. Okay. So he's so cute. I love it. Anyway, back to this. So we're gonna get our Raven, and we're gonna get actor location. And then we're going to promote this probably to a local variable. I don't think we'll need it elsewhere, at least not on like a almost tick basis. So we'll set the Raven location. Then we'll get the boy, and we're gonna get remember we made that, yeah, that thing. We're gonna get the Raven anchor point, and we're gonna get the excuse me, it's a little late here. Oh, it's almost 12. Dang. So we got the anchor. We'll promote it to a local variable, and this will be the follow point location. And if, let's see. Okay, so we've got where he's currently at, where we want him to be at. We did this a lot with the camera yesterday. It's also useful in moving pawns around if you don't necessarily want to use like nav meshes and stuff and have like pathfinding. This is kind of an easy way to do that. I forgot that I need delta time. Crud. I don't want to pass it. Oh, that's right. Wait, I don't want to use the tick for this. Get world delta seconds. There we go. This is the, if you look here, it return. I can't speak. I'm sorry. It returns the frame delta time in seconds adjusted by time dilation. Essentially, how much time has passed between the last frame, more or less. And so, let's put the interp speed to like 2. And then we'll grab the Raven. And we're going to set actor location. To that. Now, keep in mind, this is development is an iterative thing, right? So it is very possible, in fact, almost probable, that at some point I will come back and replace this with something a little bit more intelligent. Now, the reason is, if the Raven is pretty, like, reasonably close to the target that it's going to follow, it'll look fine, right? However, let's say the Raven is like a gajillion units to the right. With that kind of interp speed, I fear that the Raven would come zooming at supersonic speeds to reach its target location. So it may be adjusted later. But hey, we've got the location part taken care of. But if the Raven's following the boy, obviously we want him to look at the boy, right? So we're gonna do some shenanigans with the look at function, and so basically you could take one location and a second location, and there's this fun function called find look at rotation, and it'll tell you the rotator that you will need to look from this location to this location. Now the thing is, we don't necessarily want to, thinking this through, we don't necessarily want to rotate on all axes, right? We don't want the Raven, if the Raven's floating like this, we don't want him to be like skirt. Like, we want him to rotate this way and maybe this way. Like, if he's right over the boy, he can look down, but certainly not like wonky, right? So let's get the Raven location again. Do I want to do it this way? How do I want to do this? So I've got I've got the look at rotation for the follow point. Yeah. Yeah, okay, let's take the pitch. Because I don't want him to pitch too far forward, regardless of where he is. So let's clamp that to a float. Let's allow him to go a little bit, but not too far. We'll clamp it between -10 and 10 degrees. And then the X, so the roll, right, I think we'll just keep that. So if I do make rotator, all right, we're going to keep the roll. We're clamping the pitch. And then the yaw will be wait, isn't it just going to be this as well? Yeah. Yeah, right? I think that's right. Oh, you know what? I messed up. Sort of. Because the follow point. Dang it. Because the follow point here is... Okay. I'm thinking and I'm trying to explain at the same time. So this function is follow the target actor. The problem is that I'm using the boy here instead of the target follow actor. The reason I did that is because I was thinking ahead of saying, oh, it's because I'll need the Raven anchor. However, anyone that the Raven is following needs to have a Raven anchor, more or less. Okay, let's make a note here. We'll keep going for the sake of this video, but I'm gonna make a little note to do. Make an interface call for get Raven anchor. And like I mentioned last time, I'll make that in orange so that I know that it is important. Okay. So I'll do it right over here because I can do get the follow actor, right? And we'll find the look at rotation to there. Get world. Ooh, why didn't? Oh yeah, get actor location. All right, and then we will split this one again, and I'm going to take the Z from this one, right? So, yeah. Yes. All right, and then we'll take the Raven again, and we'll do set actor rotation. Pew. And we'll set that as the rotation. So did I cover? We got X, we got Y, we got Z. Okay. let's see if this works. I'm gonna take the Raven, move him over a little bit. Let's hit play. Uh-oh. Where's our Raven at? Oh no. He's gone. He's gone. Where'd he go? Oh Lord. Okay. Lots of errors. That's fun. Alright. Error on set follow point. That's probably because the boy... Okay. The boy is probably null at that point. As in, we're trying to... The behavior tree is trying to run this function before we've set a value for boy. So because I'm going to change this later, I'm going to go ahead and do target follow actor convert to a validated get. And as a matter of factor, wow. As a matter of fact, we're going to do this right up front. So if we don't have a valid target follow actor, we're not going to do anything. So let's try that again. Nope, I think okay. Our Raven's not moving at all. Why? Any errors? No errors. Okay, so let's see what's going on here. So let's set a breakpoint here. And we hit play. Interesting. Very, very interesting. So our target actor is never being set. The reason that we know that is because if it was, so we know this function is getting called a lot because of all the errors that we had in the console trying to access boy. So what that means is if we don't have, so we're trying to set all this up on possess. My instinct says that the possession of this actor is happening before the boy gets spawned in here. So there's a couple ways we can handle this. And I think the easiest way is to just kind of guarantee that the boy is going to be in the level when we start playing. And the way that we can do this is we can get rid of this player start capsule, and in the details of the boy, if we go all the way down, I think it's all the way down at the bottom. Nope. Where is it? Here we go. Auto possess player. We are going to possess player 1. So we'll save and hit play. Aha! And now we are hitting our breakpoint. And I think that was the whole issue. So let's hit play. Oh, look at that. We got a little bird buddy. Look at him following us. He's awesome. He's a good bird boy. Our camera is still a little wonky for some reason. And now I don't know if you can tell, but when our camera went wonky for a second, left, right, up, and down are no longer directly on axis, which is really weird. So we're gonna figure out what caused that. So far we're good. We're good. Let's go up the stairs again. That's when it happened last time. No? Oh, this is gonna be fun to figure. What in the world? Okay. That's odd. Oh, okay. This is how much time do we have left? 5 minutes. I don't know if I can do this in 5 minutes. Let's see. We're gonna try to sprint through this. I want to get the bird instead of just like hover flapping. Let's get him actually like really moving. Ravens, crows, meshes, skeletal mesh. Let's create an anim blueprint. And ooh, I hit caps lock, I think. Did I? Nope. Anim BP Raven. All right. Save all. Boop. Let's create a state machine. Where? State machine. Good grief. We'll call this locomotion. Cool. Need some things in the event graph real quick. On initialize animation. Nope. That's not right. Is it? Different initialize animation. Oh, yeah. Duh. Get pawn owner cast to BP Raven. Cool. Then we're going to promote to variable. We'll call it Raven. Cool. So here's the tricky part and why I might change this later. Matter of fact, I'm not going to be able to do this in 5 minutes because now I'm suddenly. Remember, I said like this is a little weird, and I'll probably change it later. So what this actually needs to do is it needs to drive the character input, and I think I also messed up by making the Raven a pawn. I think it should have been a character because now, as you can see, I don't have access to the character movement component, which I need in order to drive this by input rather than setting the actor location. Because if in the anim BP blueprint now, if I were to do Raven, I can't even get the speed anymore. Which that was a, I don't know why I did that, honestly. I think I was trying to keep it as simple as possible, but hindsight's 2020. So, hey, maybe that'll be the content for the next episode. So I think I'm going to call it there for tonight. We are right at 59 minutes. So, hey, thank you guys for joining me again for another Unreal Hour. Hope to see you next time. Have a good night, everyone.